Jaden, Jackson, I'm thrilled you guys are here. So we can review for our test on absolute value piecewise and square root functions. So right now what we're going to do is we're going to review shapes for graphs. Specifically, we're going to talk about the vertex for each of these kinds of functions. We're going to spend a few minutes talking about domain. We're going to be finding the range for each graph. And then we're going to be reviewing piecewise functions. That's really critical today, and I'm looking forward to it. So let's jump right on in. Here we've got quadratic functions, and here we've got the parent function, right? This is y of x equals x squared. We've got a square root function, and we know that it always adheres to this sort of curve, this shape right here. And likewise, we've got an absolute value function. And the slope, of course, is 1 because nothing precedes it. We're going to be talking very briefly in a little bit about how multipliers influence the shape of these graphs. But let's start with quadratic functions. We remember a moment ago I said that we're going to find the vertex for each of these graphs. And so let's take a look at this one right here. So I see it says y of x equals x plus 5 squared minus 4. All right, so what does that mean? That means that we're going to start at 0, 0, and we're going to be doing what? We're going to be going to the left 5 and then down 4. And I can see that that sure is the case. We're going to be counting over 1, 2, 3, 4, 5. And we're going to be counting down 1, 2, 3, 4. Boom. This is our vertex. Likewise, right here, I made a quick mistake. So I can see that it says x minus 3 squared. And so that indicates that because it's minus 3, we're going to flip that sign so it's positive, and we're going to be counting over 1, 2, 3. All right, so this is the axis of symmetry, right? But it goes up, and I don't include that in this graph. So we're going to be adding what number? 1, 2, 3, 4. I can see that it cuts across in this y-axis. So we're going to be adding, plus 4. Beautiful. Let's do a few more really quickly. When we're looking at the square root function, when we can see that it's the square root of x, it starts at the origin point. However, when we're looking at 3, square root of x plus 3 minus 5, that plus 3 indicates that we're going to be shifting 3 to the left.
Yeah, okay.
Nice. And then because it's minus 5, Jackson, are we going up or down?
We're going down 5.
We sure are, and this is the vertex. That's the starting point.
Alright.
Likewise, right here, we're going to be counting over to the left or the right 6. Jaden, what do you think? Left or right?
We're going to the right.
He says to the right 6. What do you think, Jackson? To the
I
right?
think we're going to the left 6.
Yeah.
Yeah,
Because-
it's positive 6 and you're doing the opposite.
Oh yeah, positive.
Yeah, because it's positive 6, and with that horizontal one, we're going to be shifting over 6 to the left, and then we're going up or down.
We're going up 5.
We're going up 5. Let's see. Up 5. Beautiful, and I can see that it's reflected right here in this graph.
Okay.
And then very quickly, let's take a look at this one right here. I can see that it's 3 to the left, 5 down. I can see that here. It's 4 to the left, and then 6 up. Beautiful. So once, Jackson, Jaden, you guys feel confident about finding vertex?
Yeah.
Yeah.
Nice. All right. So let's figure out what domains are. So domain represents what, Jackson?
DMX.
No.
DMX is right. What value does it represent? X values or
The X.
X.
yeah, the X value is beautiful. So we'll start with this one. So what X values are included in y of x squared?
Well, all the way, all X values.
all.
X goes to all.
So it
Beautiful.
Would, it would be
Numbers.
X,
Yep.
absolute value, or the little cross sign, then X is equal to R, because that's all real
Sure.
numbers.
Yeah.
Sure. So we can certainly write it like that. So x equals all real numbers.
Yeah.
Likewise here, x equals all real numbers.
For all functions like this, is it equal to all real numbers?
Yeah, and same holds true for absolute value functions. Nice job, dude. Let's pause. Let's take a look at square root functions because, Jackson, is it all real numbers?
For X, no.
No, it's not. So what we're gonna do is we need to think about, okay, where does this start?
For the first one?
Yeah, and specifically on the left side, what is the first coordinate? I can see that it's 0, 0, right? So is x greater than 0 or is x less than 0?
X is greater than.
Great. So is x greater than or equal to 0?
Yeah.
Yeah, so we're going to write it like x is greater than or equal to 0. Here we've got, we're looking at this square root function. We can see that what I know is that this is the dot furthest to the left. Does that make sense? And we need to think, all right, where does it line up along this x-axis? Oh, -3. Okay. So is x greater than -3 or is x less than -3?
X is greater than -3.
X is greater than or equal to -3, and we can of course always write it like, okay. I can't even see who that is.
Mason.
No, Mason, I'm gonna catch Mason later. Let's take a look at this absolute value function. We're gonna find the domain for this one as well. We found the vertex earlier, but my question to you is similar to quadratic functions. What's the domain?
To be x equals to all real numbers.
Yeah, x equal to all real numbers. Mason kind of threw me off with that one. All right, let's take a look at that last square root function. Jaden,
Yeah.
what's the domain?
For which one?
For the last square root function.
The domain.
Right here.
Here.
Yeah.
The domain is x. Wait, y is greater than or equal to.
Are we talking about x values or are we talking about y values?
Y value.
No, X, because it's domain.
Oh, so it to be x is greater than or
Good.
or equal to
-6.
-6.
Beautiful. Amazing. Beautiful. All right.
Yeah.
Tremendous. Do you guys feel confident finding domain?
Yeah.
Yeah.
All right. Tremendous. What can we talk about range real quick?
All right.
Yeah.
We'll take a look at these quadratic functions. And we know that instead of looking at that x-axis, we're going to be looking at that y-axis. What is the range? So y is greater than or less than what? We're going to find the vertex. In this case, it's the minimum. And I can see that it cuts across to where? -4. So is x greater than -4 or less than -4?
Or do you mean Y?
I'm sorry, you're right. Thank you, Jackson. Is y greater than -4 or less than -4?
Greater than.
Yeah, and is it greater than or equal to -4?
Yes.
It sure is. Beautiful. Let's take a look at this middle square root function.
Okay.
All right. So we need to find out what is the lowest point? What is the minimum? What is the bottommost?
-5.
It sure is -5, and so I can see it cuts across right there. Beautiful. I'm gonna do y. Now, is y greater than -5 or is y less than -5?
Greater than. Okay, fine, Jaden, you said it.
What is it, Jaden?
Greater than.
Yeah, because it goes up all the way here. So we're gonna do y is greater than or equal to -5. Beautiful. Let's take. You guys are staying focused. I appreciate that. Finally, range. Let's take a look at this one.
All right.
I can see that before.
This one's flipped.
It is flipped.
Yeah.
We're talking about range, so we're gonna do that y value.
All right.
And is
I
what
think it's less than this one.
you think it's less than? What do you think, Jaden?
Yeah, I think it's less.
Greater than or less than?
I think it's less than.
Yeah, less than what?
Less than or equal to 5?
Less than or equal to 5. Muy bien. Muy bien. I can see that because right here.
In Spanish.
Tremendous.
Yeah, there we go.
All right. So range. Are we feeling confident about finding range?
Yeah.
Yeah.
All right. Beautiful. So if you guys use this reference sheet, this study guide, hopefully you'll be able to figure out how to draw each function. You're going to reference your homework. What we're going to do right now is we're actually going to be drawing piecewise functions. So at the bottom of this little handy-dandy study guide, I can see that we've got two functions that, when composed together, give us this piecewise function. And so I can see that this first function is just 5. And so what does that mean? Is that a horizontal line? Is that a vertical line?
Or
Is
that
that a
would just be
diagonal?
horizontal line.
It sure is a horizontal line. And so what we're going to do.
But it stops at -3.
All right, let's see. How do we get this? All right, so I can see that's a horizontal line, 5 on the y-axis, right? Okay, so it's going across. But where does it start and where does it end? So when we look at the information on the right side of this piecewise function problem, I can see that it sort of gives us constraints as it relates to x value. So it says x is greater than -3. Oh, okay. So we know that it's on this line. It says 5. That means it's horizontal. And it says that x is greater than -3. That means that we're going to be shifting over 1, 2, 3.
It's not going to go past -3.
It's not going to go past -3. It's going to start at -3 and it's open.
Because it says greater than, not greater than and equal to.
Oh, beautiful. Love that. Tremendous. All right. So we're going to graph it like that way, to the right, of course. And then we've got, is this a square root function? Is this a quadratic?
Oh, that was like absolute value.
Yeah, and what's interesting about this?
There's a negative sign.
There's a negative sign that precedes.
Means it'll be flipped. It'll be a flipped V, so it'll be like an A without the line through it.
It sure will be flipped. You guys know what's up. You can dab. I'm excited too. All right. So we know that it's flipped. Maybe it looks a little bit like a mountain, maybe like an A. And the question is, where does it start? Well, the first thing that we did when we sat down for this little tutorial is we had to find the vertex. So likewise, we're going to need to find the vertex right now. I can see that it says x plus 4, absolute value of x plus 4, and then plus 2. If it's plus 4, are we going to the left 4 or the right 4?
If it's plus 4, it flips, it changes to negative, so.
Yeah,
So it's going down 4, right?
To the left 4.
to the left 4.
I meant to the left, yes.
You sure did, and then because it's plus 2.
We're going up 2.
Yeah, that's like the k value, right, in that vertex form that we've talked about. So we're gonna go up to this. So this is the vertex. That's like the first.
Yeah.
That's the first point. In this case, it's gonna be the maximum because of that little negative sign. Beautiful. So now here's where things can get a little tricky. I can see that it's negative 8 is less than or equal to x, which is less than or equal to negative 3. All right. So what we're gonna do?
So that means x can't be smaller than negative 8, but it can't be larger than negative 3.
That's precisely what that means. Alternatively, it means that we're going to be starting at negative 8,
Okay.
and that we're going to be following along this.
Up 1 to the right 1.
Yeah, up 1 to the right 1 because the slope is just 1. If there's no number
It's negative 1.
as a leading coefficient, then it's just 1. Beautiful. And then it concludes at negative 3. And that's it. If you do this on the test, you're going to be good money. You're going to earn yourself an A. You're excited.
Good money.
Can we graph a few of these together?
Yeah.
Let's graph a few of these together.
All right, let's, yeah.
All right, so you're gonna flip over, excellent. So we've got two functions right here. We've got an absolute value function, and we know that this is gonna take the form of what kind of shape?
Horizontal line.
It sure is gonna be a horizontal line. Where exactly?
Up 4.
We are gonna go up 4, and do we start drawing a line right there?
Yeah.
We do?
Well, we can put a point at 4.
You know
well,
what?
I can't see. Wait. X is larger than 3, so that means it can't be smaller than 3.
So that's a good question.
So you go up 4 to the right.
So here's what I know. We know that it's going to be on this line somewhere.
Yeah.
But as we discussed earlier, this is going to kind of tell us our constraints. This is going to tell us where we're going to be starting and finishing. And I can see that it says x is greater than or equal to 3.
So we're going to go to the right 3 then?
Yeah.
So what we're going to do is we're going to go up 4 and we're going to go to the right 3.
Okay.
And I can see that this is all right. This is a closed, this is a solid dot. And it says x is greater than or equal to 3. So is x going to the right, or is x going, I'm sorry, is the line going to the right, or is the line going to the left?
It's going to the right.
To the right.
It sure is going to the
And there's an
right.
arrow
And there is an arrow, and what does that arrow represent?
that I can continue going to the right as far as it goes.
Yeah, that's going on for, it is going on for forever. All right. And now what we need to do is we need to take a look at this, this absolute value equation, or this absolute value function. And it says x plus 2.
X was 2.
Where is the vertex? That's the first thing that we need to figure out. What is the
Would
vertex?
it be to the left too?
Isn't it?
It
changes to a positive, right?
Say what?
This negative changes to a positive.
It changes to a positive. So Jackson, if it changes to a positive, are we going to the right or to the left?
Left.
We're going to the right. So
We are going to the right,
Oh my god.
right?
Cheating.
Nice job. No, Jaden knows what's up. All right, so we're going to the right too. Does that make sense?
Yeah.
All right, the horizontal value flips. Okay, so if it was plus 2, then we'd be shifting 2 to the left.
Yeah, okay.
Okay, but it's minus 2, we're shifting 2 to the right. We just found the vertex. We know that this is like plus 0, right? We're not going up or down. The k, value of k is 0, so we're staying right along right there. So before we can do anything else, we need to figure out what are the constraints, where is it starting and finishing? And it says, well, x is greater than 0, greater than or equal to 0, and x is less than 3. All right, so we'll start going to the right. So x is less than 3. That's going to be open or closed?
Open.
It is going to be open. It is going to be open. And we know that the slope right here is what?
1.
It is going to be 1. So that takes the, that looks like what when we're doing the absolute value
Absolute value.
function? It's going to be,
That's just going to be up 1 to the right one.
yeah, the rise over run is up 1 over 1. And tell me again, is this open or closed?
Well, this one's going to be open.
This one is going to be open. Beautiful. So it's going to look like that. So where does this, how far over does this shift to the left? To 0. So what we're going to do is we're going to go up 1 over 1, up 1 over 1. And this is a solid, that's a solid dot.
Wait, so you go up and wait, sorry.
So the slope,
So it can't be larger than 3, but it can't be smaller than 0, right?
that's right, that's right. If hypothetically, the slope was, let's say hypothetically the slope was 2, and I'll do this in green. The vertex would be the same, right?
Yeah.
But instead it would be
go
up to
the right one.
up to the right one, yeah, and it would actually, in this case, it would stop right there, and then up to over 1.
Up to
over 1.
So it'd be what? 0, 4?
Yeah, amazing. You
So
can see that.
You treat the x like 1, you know, since you're going up to the right.
You know, we're not treating x like 1, we're treating the leading coefficient. Like, if you don't see it there, that means that's what the slope is.
Okay.
Can we do one more?
See.
Ah, muy bien. All right, so let's do this one. All right, so we can see that we've got 2 functions. We've got just this horizontal line, that's 5, you guys know that, and here we've got negative absolute value of x plus 6 plus 2, and here we've got this sort of the constraints. So let's start with the red one, and it's 5. So what we're going to do is we're going to go up 5, 1, 2, 3, 4, 5, and we can't just start drawing a line like this. We need to think about where it starts and finishes. And
X is greater than negative 2, so
Uh-huh.
it would start at negative 2.
Great. Is it open or closed?
It would be open.
It sure is open. Amazing, and it's going to go like that.
Okay, so yeah, so when you went to 5, then you went to the right too. Is that it?
Or to the left.
We're going to go to the left too because
It's negative
Okay,
2.
since it's negative. Okay.
yeah. All right, and so we're halfway done. Now we've got to figure out how to graph this absolute
Well,
value
it's a
function.
negative, so you know that absolute value is going to be flipped.
Yep, that you're certainly right. Before we can do that, we got to figure out where to start. We got to find the
I
vertex.
think it's going to go down 2.
Well,
Oh no, up 2, because it's plus 2.
also
My
the-
bad.
We're gonna go up 2, but before we go up, we're gonna go to the left or the right.
6.
We're gonna go to the left 6. You're
yeah,
100.
since the absolute value of the plus changes to the negative.
Amazing. We just found the vertex.
Yeah.
And so that we know it because it's negative, it's gonna be shaped like this.
Yeah.
Awesome.
It'll be like an
All right.
B upside down.
And I know that when we're looking at these sort of constraints right here, it's gonna, x is greater than negative 7, but x is less than or equal to negative 2.
Yeah.
So what does that mean? I can see that this is,
So that means it can go all the way past negative 7, right? Or it stops at
negative 7 is less than or equal to x.
Oh, less than. Okay, well, so it stops at negative 7 then.
Totally. So what we're gonna do is we're gonna look at this, and we know that the slope is 1, Jaden. It's 1,
We'll look like this.
and we're not going like this. We're going the other direction. So I'm gonna go right here. And is it open or closed?
It'll be it'll be
This
closed.
time it will be closed since you have that little dash.
Yeah, that's absolutely right.
Yeah.
And so similar to before, the slope is 1, and we're gonna be going to where it says negative 2. All right. So we're gonna go down 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1, and I'm gonna stop right there. And when we're stopping right there because it's negative 2, and I remember that x is less than or equal to negative 2, so we're gonna pause right there, and we'll seal it up. Draw a line. Amazing. All right, guys, I have a couple questions for you. So if we say if I say that I don't know if you can see this, the f of negative 6, what's the y value? If the x value is negative 6, what's the y value?
The y value is then 2.
It is 2.
Yeah.
What's f of negative 4? It would be,
Zero.
It should be 0.
it sure would be 0.
0.
If f is, f of 4 would be what? If the x value is 4, what's the y value?
5.
It's going to be 5. So you're going to see questions just like that. We're going to wrap up this 20 minutes of tour. You guys were amazing. Nice job, Jaden. Nice job, Jackson.
That was great.
We like it.
Thanks, guys. You guys are gonna earn an A on the
Alright,
test
bye.
tomorrow. Thank you.
Bye.